Okay, now I'll open jump again, and we will use the filler row data for the Pareto charts. So as we can see from just the failure column, we have many factors. They're all categorical. Now basically we're gonna count all the factors. And why are we gonna count the factors? Because we want to see like which is the one who is affecting our process the most. And so we can, if we get rid of that factor, we can improve our process. So now let me show you how to do this and jump. We go to quality and processes. Quality and process. Pareto plot. The failures, the cause, and okay. So from this Pareto chart, we can see that the contamination, the oxide defect, and the miscellaneous are mainly 80% of our problems. Because these are important, but are not as important as these three right here, because these are the ones who are, let's say, the most common in our processes. So if we get rid of these defects, or we can reduce the amount of contamination or oxide defect and miscellaneous, then we will improve our process. Okay, so that was for the Pareto plot. Now let's move on to the control charts. Okay, control charts. So control charts are statistical process control tools used to determine if a manufacturing or business process is in a state of control. In this particular example, only two types of control charts will be explained: the X bar and the R chart. So some special features: in the control charts, we will always find upper and lower control limits, a mean line, and points representing the data. Also, we'll find outliers, maybe trends, and others. And how do we determine that our process is in control? With points out of control. If we find like more than 2 points out of control, then we can say that our process is out of control. If there are 5 points all above or below the mean, then our process is out of control. And if we find like a run of 5 points going up or going down, which means like there's like an upward trend or a downward trend, then we can tell that our process is out of control. So now let me show you how to, like a brief demonstration of the control charts in SAS Jump. So we're going to use for this particular example our airport data. As we can see from our airport data, we have the day, flight, and the amount of delay. And here we have like some reasons for our maybe failure, or like there was something going on that day, and that was our flight was delayed, or any other things. Okay, now we go to analyze, quality and process, control chart, export chart. And for the process, we're going to use delay, the amount of time that the flight was delayed, and for sample label, day. So we click OK. Now here we have our export chart and our R chart. So let me explain a little bit what is going on right here. So from this graph, we have 1, 2, 3, 4, 5, 6 points below the mean line, which means that this This data is out of control. Here we have 1, 2, 3, 4 outliers because this is our lower control limit, upper control limit. So this data is definitely out of control. And we can take a look. Oh, by the way, the X bar chart basically means that this is the mean of the means per each day. So each day we have the mean, and the X bar is basically the mean of all the means, which is this one. And the R chart value, which is basically against the mean of the range per each day. So here 2 points, 3, 4 points out of control. So this data is definitely out of control. Well, now we're gonna move on to the graph builder. Okay, so for the graph builder, we have for this particular case, only 4 different charts or graphs. And after I talk about each of them, I'm going to show you the jump demonstration. So the type of charts, we have 4 types: line charts, box plot, contour plot, and mosaic plot. For the line chart, this is a chart that displays data points as a series. It is used to show data trends, seasonality, etc. over multiple periods of time. So it basically is a time series analysis, or just a chart of the time series, sorry. Let me show you how to do it, and jump. Okay, let's go jump. We open the Australian tourism. Make it a little shorter. Okay, so here we have the Australian tourism. It's on the date, establishment, birth places. So we're gonna use the data revenue, we call them revenue, and we're gonna go to graph builder, and let me do a little bit shorter for you so you can see. So our revenue will be our y values, y variables, and we're gonna display it by date. And this is the line plot. As we can see, here's our time series variable using our line plots. So it will go from year to year, and we can actually see that there's a seasonality in our data, and also an upward trend. Seasonality, and obviously each year by year is increasing their revenue. So they're doing a great job. Well, let me go to the next one, which would be the box plot. Okay, the box plot is a chart that graphically displays data while concentrating on quartiles. It is used to easily let us identify outliers and slash quartiles in our data. So let me explain you a little bit more with the data table in JUMP. Okay, open the car physical data table, JUMP. So here we have the model of the car, country, whether the car was small, medium, compact, large, the weight of the car, turn cycle, displacement, horsepower, and gas tank size. So let me run the graph, open the graph builder, and I'm going to show you how to do the box plotting here. So for this case, we're going to use the country. So whether you come from Japan, USA, or different country, and gas tank size. Then we click on box plot. From this chart, we can tell that the mean, this is the line, this line in the middle is the mean, or more than the mean is like the quantile, the 50% quartile, or the middle point. This is 75%, 25% for a single case, and these are from 75 to 100, from 0 to 25%, and if you have some outliers for the USA. So there are some cars manufactured in the USA that have a gas tank size that is going out of their control. Here we can see that the variability for Japan is larger than the variability for other countries and for the USA. Meaning that they have more, maybe they have more factories, or maybe they have more models. Can be anything. Okay, let's move on to the next plot. And now let's talk about the contour plot. It is a chart that joins points of equal value on a straight line and displays them as a plane curve. It is used to represent functions with a two-dimensional input. Well, let me show you how to do this in Jump. Okay, let's open Jump again. We're going to use the same table, but for this particular case, we're going to use the type of the car with the horsepower. So we go to graph builder. This is the type, or X factor, and the horsepower, or Y factor. Oh, sorry. Now, if we click on the contour plot graph, then we can see like basically shades. But what this shade means is that whenever it is wider, it means that it has more points in there. For example, it has more points. This part of the contour has more data for the large one than it has for the sporty one, and so on. And now let's go with the last one, which would be the mosaic plot. So it is a chart that graphically displays two categorical data, and it is used to compare two sets of data. Now let's see how it looks in Jump. Okay, let's go to Jump, and for this case we're going to use it Titanic passengers. So here we have their class, whether they survive or not, name, sex, age, and many other factors. But for this case, we're going to just use whether their class and whether they survive or not. Just go to graph builder and use their class and whether they survive or not. Now let's click on the mosaic plot. This basically looks like a continuous table, and these are the probabilities based on whether they survive or not and their class. Okay, now let's move on to the next one, which is linear and multiple regression.